Okay, guys, we are on the last question. And honestly, I think what I'm going to do is I'm just going to do A, B, and C, and then D, because I'm not 100% sure and don't know how to fully explain it. I'm going to leave that, but I'm going to do A, B, and C. And I think that's like where the actual partial derivative, the second partial derivatives are. So I think that's the most important part. So let's start. So for the function z equals fxy, where x is equal to g r theta and y equals hr theta, I use the derivation from class to show that this is it. So in essence, what it's asking us there is to say that z r is equal to zxx. Okay, before that, actually what I'm going to do is I'm just going to write the chain of dependency. And what that means is it's going to be z x, y, and then from x we have r theta, from y we have r theta, and then we're saying that zrr is equal to zxx plus rx, not plus, times rx squared plus zx times xrr is what I meant to say. There you go. xrr plus 2 zxy xryr plus zy yrr plus zyyyr squared. Let's start. So the way we can view this is we need to take first zr, and then of the r, we need to take another r. So zr is equal to zxxr plus zyyyr. That would take the partial derivative of r. So here what we need to remember is that there's a product rule whenever we take the derivative of this and this. So then, if we actually write it out, it's going to be zx rxr plus z plus, and I almost forgot the product rule, which I was saying don't do. Then it's going to be zx xrr. Again, because r here is in the same level, there's nothing special, there's nothing hard, plus zyr zyr yr plus zyy. Okay, so then what we need to start with, sorry, it was lagging a bit. Okay, so we need to figure out what zx r, what the partial derivative there is. So that's what I'm going to do. So if we say that w of xy is equal to zx, so then what we're going to get, and that's because again, zx is just a function of x and y, and that's why we can do this. So then what we're going to end up doing is that we're going to get wr, and wr is equal to wxxr plus wyyyr, and then we replace it, so we get zxxr plus wy. Sorry, the reason I keep like stopping for seconds because I have an eraser button, then I keep losing it. That's why I go and then search for it and come back. So it's going to be wx y yr. Okay, and then for the zy, they would end up being the same thing basically. Just over here would be z y yr plus z y x yr xr. I'll just do it just in case. Okay, so then we would have wxy is equal to zy. So then wr is equal to wxxr plus wyyyr, which is equal to zyxxr plus z, y, 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 r. There you go. Now, if we just combine everything and write it in a nice long line, what we're going to get is that, so over here, I'm just going to put it right here. If we see we multiply by an xr actually. So what's going to happen is, and over here as well. So when I'm writing it, and I'm just going to write it that right away like that. So then it's going to be zx xr times xr plus, over here that should be a z, not a w, zx, so plus zxy, yrxr, make it a little bit bigger, yrxr, plus zx xrr, plus we reach here, so zyx, okay, over here it's actually yr, right over here, sorry, zyx, zyx, xr, yr, plus zyy, yr, plus zy, yrr. So now, if we just write it a bit more neatly, we see that this term and this term are the same. So zxx, and then xr times xr is just xr squared plus zxxrr plus 2 zyx xryr plus zyyrr plus zyyyr squared. And now the second part of this, and we just confirmed basically what was said over here. The second part then is asking to basically imagine that we had theta, but if we imagine that we had r instead of theta, what would actually happen is that all of this would just be the exact same, just we would place the r's with theta. So if I were to rewrite it quickly, so it would be zxx x theta squared plus zx x theta theta plus 2 zyx x theta y theta plus zy y theta theta plus zyy y theta squared. The reason that matters is because now we reach question 3, and in question, or C to be more exact, it says, you may recall that the transformation from Cartesian to polar coordinates is x equals r cos theta, y equals r sine theta. Use the above results to show that this. Again, I'm not really going to read it because I'm a bit lazy, but yeah. So let's do it. So what we right away notice is that basically on the left here, this is zrr, and this is plus 1 over r zr plus 1 over r squared. And then it's here, it's z theta theta. On the left side, we get zxx plus zyy. And so what we basically need to do then is we're going to go through and basically plug and check. So why? Because this is actually equal to zrr, and this is equal to z theta. And so what we're going to need to go is we're going to need to find zrr, plug it in, zr, plug it in, 1 over r squared, z theta theta. So the way we're going to do that then is we actually have the relationship between x r cos theta and y r sine theta, I meant to say y r and theta and x r and theta. So then what I mean by all of this is that we can kind of start building the relationships between them. Okay, what I mean by that, so if we notice here we have xr squared, xrr, and so on and so forth. So we're going to start doing that. So if we have, I'm going to start finding that is what I meant to say. So we have x equals r cos theta, and then we have over here, okay, I'm going to move this because I like x to be on the left. There you go. And we have y equals to r sine theta. So then we're going to get x in terms of r is equal to cos theta and then xrr is equal to 0, no r, and yr is equal to sine theta, yrr is equal to 0, and then right below that we can write x theta. So x in terms of theta is going to be r, so x theta is negative r sine theta, because the derivative of cosine theta is negative sine, and then x theta theta is going to be negative r cos theta. So then y theta is equal to r cos theta, and then y theta theta is equal to negative r sine theta. Bam. Cool. Now what we can do is we can start the plug and chug I was talking about. So then ZRR over here. So ZRR is equal to ZXX plus XR squared. XR squared is right over here, so that's just going to be times cosine theta squared, or cos squared theta is a better way to write it. ZXXRR, XR is 0, so this term is gone, plus 2 ZY XR YR, so that's going to be plus 2 ZXY XR YR, so that's cosine theta sine theta. YRR is gone because it's 0. And then plus ZYY YR, over here we see YR squared, so sine squared theta. So plus ZYY sine squared theta. Bam. Next, we have ZR. We need to find ZR. So ZR, if we go back, we see that ZR is actually ZX times XR plus ZY YR. So I'm just going to write that quickly again. Equals to ZXXR plus ZYYR, and that is equal to ZX. XR is cosine theta plus ZY times sine theta. And bam, finally we get to Z theta, and that is equal to, so ZXX theta squared, that is ZXX x theta squared is just going to be r squared sine squared theta, r squared sine squared theta. It's going to get a bit tedious, so plus zx x theta theta, zx theta theta is equal to negative r cos theta times negative r cosine theta. Next, we're going to have plus 2 zyx times x theta y theta. So x theta y theta is going to be negative r squared cosine sine theta, or negative r squared cosine theta sine theta. Sorry, plus zy y theta theta. Y theta theta is negative r sine theta, negative r sine theta, plus zyy y theta squared, which is just going to be r sine squared theta. Y theta squared is r cos squared theta, because that's y theta theta, but we want y theta squared. That's why that's why what I said before was wrong. So it's going to be r squared sine squared theta. Bam. Okay, now we just need to add all of that up, right? Keeping in mind what's happening. So we're going to get, it's going to be a long line, but it's going to be super beautiful. I promise you, you're going to be like, wow, that was awesome. Plus 2zxy cos theta sine theta. And I'm sorry I'm like writing the zxy over here. Plus zyy sine squared theta. Okay, ZR. Now, ZR, what's important to notice is that all of the terms in there are divided by R, because we're at 1 over R. So I'm just going to, instead of rewriting it a couple of times, I'm just going to start dividing everything by R right away. Okay, so just keep that in mind when you're seeing this, that this ZR, I'm just dividing by R. So it's going to be plus ZX cosine theta over R plus ZY sine theta over R. Perfect. Finally, we're going to add 1 over r squared theta, 1 over r squared. So again, just like last time, when I'm going through all of this, just keep in mind that I'm already dividing everything by r squared. And that's why it's not exactly as I have it on top. So then we're going to get zx and r squared theta sine squared theta divided by r squared is going to be sine theta. So it's sine squared theta plus, and hopefully you start to realize what's actually going to happen. So plus zx. Actually, just over here, I'm going to write in the negative over here. So it's negative zx divided by r squared. So it's going to be cosine theta over r divided by r squared over here. It's going to be negative 2 zyx cosine theta sine theta. Again, divided by r squared here. So plus zy. Again, it's a minus there, right over there. Plus zy minus zy sine theta over r plus zyy sine squared theta. Let's start simplifying things, guys. The happy moments in life when we get to simplify. So over here, 2zxy cosine sine theta, negative 2, bam, canceled. You just got canceled. 2y sine theta divided by r, bam, and over here, bam. And so what we're left with, yeah, my thing's not liking what I'm doing apparently. They're just protesting. Cosine squared theta plus zyy sine squared theta plus zxx sine squared theta plus zyy cos squared theta. Z. Perfect. Now what we're going to notice actually that it's very simple. Because we group these two terms together, we factor out zxx, we're going to get cosine squared theta plus sine squared theta. And then over here, we're going to also do the same thing, so plus zyy cos squared theta plus sine squared theta, and it's happy hour because both of these are 1, so we're going to get equal to zxx plus zyy, which is exactly what we wanted to prove when it scrolls up, which is exactly what we wanted to prove right here, zxxy, zyy. And then the blurb, this is an important relation because the differential equation, this is equal to 0, is called the Laplace equation, so apparently it's called the Laplace equation. And therefore something else important comes from it in the equation polar coordinates. I don't know much about it. Over here, what you're going to notice is that you're basically then going to use this fact that that z is constant, so this disappears, and this disappears, so all you're left with is this, and that is equal to 0. So basically, sorry. So because z is constant and z is constant, what am I saying? R is the only thing you care about, so that's why this disappears, I think. Again, I'm not sure, I didn't really prepare, but look it over, it's not too bad. What you basically end up doing is you end up integrating in terms of r. So over here the dr disappears, and then you kind of solve for your equation. If you really want me to, I guess I can try to take it up later, but I think this was the most important part, getting the partials in there. So again, but if you want me to take it up tomorrow, maybe I'll do the rest of problem set 4 and problem set 5, and maybe this part. But just, I guess, tell me if you guys want that or not. Have a great evening.